We can use the horizontal line test to identify one-to-one functions. From there, we can note that any one-to-one function and its inverse are symmetric with each other about the line y equals x. So a function and its inverse, or the graph of a one-to-one function and its inverse, are reflections of each other across the line y equals x. In example 4, we're given a function which we'll call y equals f of x, and we're given this line of symmetry y equals x. The horizontal line test would tell us that y equals f of x over this specific domain is a one-to-one function. What we can do then is form the function y equals f. Kind of looks like we're writing f to the negative first power, but it's really just a notation for the inverse function. So we can construct this function inverse of f by finding the reflection of a few key points along that path of f of x. For instance, our curve f of x passes through the points -2, -2, 0, -1, 2, 1, and 4, 4. If we were to reflect each of those points across this line y equals x, the points at the left and right end would stay right where they are since they're on that line of reflection. Our remaining points would be reflected across this line, giving us two new points, -1, 0, and 1, 2. And then what we can do is sort of sketch what the reflection of that curve would look like. Someone who drew a little bit better would get a better picture here. But essentially what we have is that same curve, and what it should look like is its perfect reflection across that line y equals x. What we can notice is when we flip those points across that line of reflection, what we're doing is essentially flipping each of those xy coordinate pairs. So with our function f of x, every coordinate pair xy, when we make that reflection, becomes a new pair y comma x. So essentially those coordinate pairs are just being flipped. We had the point 2, 1, and then the point 1, 2.